create a raster stack. So I'm going to get rid of all of this and create a new title. Oops. All we want is the title. I'll just create it manually. Okay, so you should already know what a raster stack is based on the pre-module PowerPoint. And it's basically a bunch of raster layers with all the same parameters, same extent, resolution, same CRS. Everything is the same. The values can be different, of course, but all of these rasters get layered on top of one another to create a raster brick. And when you're processing raster data, this is sometimes easier because you don't have to manually modify each raster. You can modify them at once, crop them at once, and it just streamlines your workflow. So we're going to use 3 different rasters of air pollution data to create this raster stack. And the air pollutant that we're looking at is of nitrogen dioxide in Nova Scotia. So of course, the first thing we need to do is import the rasters that we want to layer on top of each other. There are 3 rasters. So let's pull open the data folder. And here they are. It's NO21_NS, 2, 3, and so on and so forth. So these are the 3 that we want to import. Always use quotations. I'm going to copy this for the other 2 rasters. These files are a little bit larger, so if it takes a couple seconds, just be patient. Let's plot one to see what it looks like. Okay, so you'll notice that it's not as high resolution as the NDVI data that we were working with, but it is air pollution data. It's for nitrogen dioxide, which is a fossil fuel related pollutant, and it's actually very closely related to, it's very closely associated with traffic emissions. So this is for Nova Scotia. The values are quite small because we're looking at moles of NO2 per meter squared. Nevertheless, we're going to stack these on top of each other and create our first raster stack. So I'm going to create a variable called NO2 stack, and the function is just stack. So we've created 3 rasters here, and if we take a look at them one by one, you'll notice that everything is exactly the same except for the source. So all the parameters that we reviewed in the last section are the same, and that we can confirm that by using compare raster. So we used compare raster. We can see that they're both the same. Let's do the same thing for the 3rd one. It's still the same. So that means that we can go ahead and stack them. And to stack them, all we need to do is list out all the rasters in this function. And that's it. We have a raster stack. So let's clear this and explore that a little bit. So here's our raster stack. And you'll notice that most of the parameters are still the same, but there are a few differences. So the parts of this variable that are the same as the individual rasters are the resolution, the extent, and the coordinate reference system. The names now have more values. So because we have 3 rasters, we have three different names, and each name is the data for the raster. So we have tropospheric NO2 density for this first raster, and then the same one for the other ones. So the only difference is they're indexed by the layer. And finally, we have a different class, which is a raster class. And then in the dimensions, we have the same number of rows and columns, but the difference is we have 3 layers now instead of 1. And that's because we layered 3 rasters into 1. So I really like using raster stacks when I'm running machine learning models or when I'm running any sort of project that involves working with a lot of different rasters. I create raster stacks because they're all in one place, all stacked, which means that they're all consistent. If you are given a raster stack by someone and you want to check the number of layers, you can also just use n layers. And you can see that there are 3 layers in the raster stack. So one of the things that I use raster stacks for a lot is when I'm running machine learning models or any other type of statistical model. I like creating raster stacks with all of my independent variables because it means that they're all exactly the same as we can see here. They all have the same dimension, resolution, extent, and everything else. And it just makes a very clean go-to place to access all of my independent data for machine learning models. And what I do is I'll create a raster stack with all of my variables, and then I'll convert that into a data frame to run my model. So I can show you exactly how to do that. What you do is you run a function called as data frame. And this allows you to convert your raster stack into a data frame. I am going to save this as a variable called no2df for data frame. And all we need to do is import or outline the stack. For us, it's no2 stack. And then I also want to add an additional argument, which is xy equals true. And what I'm telling R is that I want to see the x and y coordinates for each row, for each cell. And when you do this, it'll provide that to you. Otherwise, it won't write anything. So let's run that. It may take a couple seconds because it's a lot of data. Okay, so our data frame has been created, and we can just take a look at it using no2df. Actually, let's use the head function because it's a lot to look at. Okay, I'm going to run that again. There we go. So here is the data frame that we just created using the asDataFrame function. You can see the x and y coordinates have been provided, and you have data for each pixel for each stack, for each raster layer. So here are the data for the first raster, here are the data for the second raster, and so on and so forth. So you can quickly turn any raster stack into a data frame by using this function, and from then you can very quickly build your models. So it's very straightforward to use. Now this is a large data frame, so I'm going to crop it a little bit so that we can export it to a CSV, and it's just going to make our life easier for the purposes of this course. You can of course export the entire CSV for a project that you're working on or for work, but I just don't want you to come across any sort of memory errors, so let's crop it. So to crop it, we need to outline which rows we want. So you need square brackets, and then you need square brackets with a comma in there. And the left-hand side of the comma is where you outline the rows, and the right-hand side is where you outline the columns. So I want 100 rows. So we do 1:100. And then I want all the columns, so I'm going to keep that as is. Let's run that. Let's run this, and that's that. And now we can use write CSV to export these data. Okay, so that's done. Let's pull open our data folder and see what it looks like. So there it is, NO2DF. And there's our data. The rasters, the data for each of the rasters are located here, and then we have X and Y coordinates. So that's how you can convert data for multiple rasters into a data frame. You import them, you stack them, and then you can convert that into a data frame and then export it. And this is really great if you want to do summary statistics or do other type of transformations for a model that you may be working on.